Proxima Centauri Bb, Earth 2.0. Proxima Centauri. Alpha Centauri is a star system made up of three main stars: Alpha Centauri A, Alpha Centauri B, and Alpha Centauri C, better known as Proxima Centauri. Of these three stars, Alpha Centauri B is the one that most attracts the attention of astronomers because around it orbits two rocky planets very similar to Earth, which are within the habitable zone and could even have life. When astronomers detected the BLC-1 signal, they couldn't help but think, even for a moment, of the possibility that someone out there was trying to contact us. Proxima Centauri Bb. Proxima Centauri Bb is a rocky exoplanet very similar to Earth with 1.17 Earth masses. It is located in the Alpha Centauri star system, making it the closest extrasolar planet to Earth's solar system, and has all the conditions to host life. What mysteries await us in this world? Let's get started. In astronomy, it is considered exoplanet or extrasolar planet to any planet orbiting a star different from the Sun. In this sense, stars with planets should be regarded as solar systems independent of ours. The star system of Alpha Centauri contains three stars. 1. Alpha Centauri A is a yellow star very similar to the Sun. 2. Alpha Centauri B is an orange dwarf star. 3. Alpha Centauri C is a red dwarf with a low luminosity that is imperceptible even with a basic telescope. Alpha Centauri A and Alpha Centauri B orbit each other every 80 years, and Alpha Centauri C orbits around the previous two. For many centuries, this system was considered a single independent star like our Sun, but from 1700, astronomers such as William Herschel realized that they were indeed two gravitationally joined stars. More recently, on October 16, 2012, the European Southern Observatory, ESO, officially published the observed remarks demonstrating the possible existence of an extrasolar planet in orbit around the star Alpha Centauri B. Of course, this news caused a furor in the astronomical community, not only for the fact that it had found a new exoplanet, but it was one right on the star closest to our solar system, which makes it an excellent candidate to be the first to be visited by humans in the future. The closest exoplanet to our solar system was discovered with the High Accuracy Radial Velocity Planet Searcher, HARPS, of the Astronomical Observatory of La Silla, located in Chile. Among some of the essential features that have been discovered so far about Proxima BB is that it is a planet slightly larger than Earth, so it should have a gravitational pull force similar to that of our world. It also receives an amount of light very comparable to that which the Earth receives from the Sun. And perhaps the essential characteristic is that, as well as our planet, Proxima BB is also located within the habitable zone of its solar system. Habitable zone. The habitable zone is a region of the solar system in which any rocky planet that is there and presents ideal conditions for the formation of organisms will have high probabilities of containing liquid water, the fundamental element for all living beings that inhabit the Earth. In the case of our solar system, the habitable zone covers the region that goes from the orbit of Mars to the orbit of Venus, and the Earth is located right in the middle of the habitable zone of our solar system. A rocky planet with little mass contains a low concentration of greenhouse gases, so would have to orbit the innermost region of the habitable zone so as not to cross the melting point and be subjected to global glaciation as what happens on Mars. In contrast, a more giant and more massive planet will have a higher concentration of these gases. If it remains at the outer limit of the zone, a habitable planet can suffer a runaway greenhouse effect similar to that of Venus. It is because even though Venus, Earth, and Mars are in the habitable zone, only the Earth can have liquid water. Venus is at the end of the habitable zone closest to the Sun and is therefore very hot, while Mars is at the far end of the habitable zone and therefore suffers an eternal winter. The Earth is right in the middle, so it is a paradise for life to flourish. Proxima Centauri Bb orbits its star in just 11.2 days, in contrast to Earth's orbit around our Sun for a year. In Proxima Bb, the years last only 11.2 days. This means that Proxima Centauri B is much closer to its star than Earth is to the Sun, but is it as close to a star as it can be within the habitable zone? This is because the star it orbits, Proxima Centauri B, is a red dwarf, that is, a much smaller, more relaxed, and less luminous star than our Sun. which is why Proxima BB receives about the same amount of solar energy from its star as the Earth gets from our Sun. In addition to this, data recorded by the European Southern Observatory (ESO) indicate that Proxima BB is a rocky planet slightly larger than Earth. In short, Proxima BB is a planet quite similar to Earth, so much so that it could even host living things. The BLC-1 signal. On April 29, 2019, the Parkes Murayang 64-meter radio telescope in southeastern Australia detected a strong signal from the star Alpha Centauri, the closest star to our solar system. This raised alarms in the astronomical community in charge of searching for extraterrestrial life. A star has two potentially good planets to host life in this system. Was this signal a call from our extraterrestrial neighbors telling us, "Here we are," or was it something else? The mysterious signal coming from the star closest to the Earth was discovered last year by Shane Smith, a college student at Hillsdale College in Michigan, who worked as a research fellow on the Breakthrough Listen project. At first, the signal was taken as a simple interference, some signal coming from a nearby device that interfered with the radio telescope. Still, after an exhaustive analysis by Smith and his tutor Danny Price, they decided to publish the signal and its research in the Slack channel of Breakthrough Listen, a program that has its primary objective, the search for extraterrestrial life in the universe, coordinating its efforts with telescopes and radio telescopes around the planet, has a millionaire fund and the support of hundreds of researchers, scientists, and astronomers from around the world. The signal, baptized as BLC-1, acronym in English of Candidate 1 of Breakthrough Listen, Smith, Price, and a large group of colleagues began to shuffle possible explanations, from satellites not cataloged to transmissions of space missions. Still, nothing coincided with the signal, which had a different frequency to those used in devices on the ground and lasted 5 long hours. Everything indicated that the signal came from Alpha Centauri. But a year later, the University of California, Berkeley astronomer Sophia Sheikh would declare that due to its frequency and bandwidth, as well as its unique signal that was not detected again, it is most likely that the BLC-1 signal was only a radio interference of human origin, coming from a technological device located on the surface of the Earth. Earth 2.0. Although for now Proxima BB is one more exoplanet in the long list of exoplanets we know of, the fact that it is the closest to our solar system makes it an excellent candidate to be the future home of humans. Since its coverage in 2016, this extrasolar planet has done nothing but awaken enthusiasm for human exploration, and missions are already being planned to send the first exploration probes to this planet. The most realistic of all is the Starshot project. Starshot project. In 2015, cosmologist Philip Lubin of the University of California, Santa Barbara, UC-USA, unveiled the first realistic plan to send a spacecraft to the star Alpha Centauri in the coming years. The big project consisted of manufacturing micro-spacecraft the size of chips that will weigh less than a gram. These ships would be put into orbit and have solar sails like those used by the Japanese space probe Icarus. The way in which these ships are propelled would be with a powerful laser fired from the Earth, which would be by hundreds of lasers joined in a single beam of light that with a single shot will provide the ship with relativistic speeds reaching 60,000 kilometers per second, or 250 million kilometers per hour. That is 15% of the speed of light, so they could get to Proxima Centauri in just 30 years. The most impressive thing about this great project is that it is based on physics and technology that already exists. All this technology, as well as the fundamentals and ideas on which it is based, do not require technology that does not exist or new physics. Everything is possible. It is only necessary to afford it and, of course, create it. According to the team of experts working with Lubin and prestigious scientists like Stephen Hawking, this is the first possible interstellar technology that we could do in our lives affordably. Still, they face the most significant challenges, creating a powerful laser to boost the ships. This is the most difficult, not only for the technological part, but also for the political part. There's usually no problem when you talk about sending spacecraft to other stars. Nobody's affected or harmed. But if you start talking about shooting with lasers, people get very nervous, says Joan Johnson-Freese, a professor of national security affairs at the U.S. Naval Warfare University. There is great fear when working with this type of technology since they can quickly become powerful weapons. Jones suggests that for the project to have a promising future, International agreement will be needed to guarantee a peaceful use and only for scientific purposes of such a powerful laser. For now, the project, so-called Starshot of the Breakthrough Initiative, is still in the creation phase, but it is expected that in the coming years, the first tests of lasers for the impulse of microspacecraft will begin to be carried out. Earth 2.0. Proxima BB is a place of great interest for the entire scientific community, especially for astronomers who do not stop thinking about what awaits us on that planet so far away. Could it be like Earth? Will it have large oceans and forests with abundant life like the ones we know? The most recent research seems to indicate that this is not the case. Recently, the ESO telescope has revealed that due to the distance at which Proxima BB orbits its star, it is highly likely that it presents Maria coupling. This phenomenon consists of a celestial body always giving the same face to the body it orbits. The simplest example of this is the Moon, and our natural satellite always gives the same face to the Earth because the time it takes to turn around its axis is the same time it takes to go around the Sun. So it is considered that the Moon has tidal coupling with the Earth. In the case of Proxima BB, it is likely that it also has a face always looking at its star. This means that on one side of the planet it is always day, and the other side it is eternally night. There are no sunrises, no sunsets. Naturally, this would influence the appearance of living beings. A planet that has tidal coupling must have, as a consequence, drastically different temperatures on each side, while on the side where it is always day, it would always be at 400 degrees Celsius. On the side where it is always night, it could have a temperature of minus 100 degrees Celsius. Both temperatures are extreme. It is improbable that life arises in those conditions. If there are no living beings in Proxima BB, could we inhabit it? That will depend on the conditions of the planet. If the current estimates are correct and it turns out that Proxima BB has tidal coupling with its star, it will be complicated to inhabit it. We could have to do it in the region where both temperatures meet, right in the middle of the day and night. In that case, the established human bases would always live in that area of the planet, where it is not day, but it is not night. We will live with an eternal sunrise or sunset that never culminates. The years would pass quickly since the planet is so close to its star. The doses of radiation are very high, so if it doesn't have a magnetic field like ours, we would have to build artificial habitats that generate electromagnetic protection that protects us from the radiation of the star. For now, everything remains in a mere and deep sleep. Still, the possibilities exist, maybe at some point in the future, when our technology and ambition allow it to send the first spacecraft to explore that world and discover once and for all if we are alone or not in this vast universe.